Hello Internet, Zach here, and welcome back to Collecting the Elements. Now I would bet you that every chemistry nerd out there has a favorite element. For example, Cody from Cody's Lab has mentioned that his favorite is mercury. My favorite may come as a surprise. It's xenon. Now you might be saying, wait a minute, that's a noble gas. Noble gases are chemically boring. They're inert. They don't react with much of anything. They just kind of sit there. Well, just add a little high voltage and that whole story changes. All of the noble gases have wonderful properties when you throw high voltage at them. Each one glows in its own unique color. Helium tends to be kind of a golden yellow, neon is an intense red, argon a pale blue, krypton a lovely lavender, and xenon a deep, gorgeous indigo. That said, xenon isn't as chemically boring as one might think a noble gas is. Xenon was the first noble gas to be found to form compounds, way back in 1962. There was an experiment wherein xenon was reacted with platinum hexafluoride and produced xenon hexafluoroplatinate. And the name xenon comes from the Greek word xenos, meaning stranger. And xenon couldn't be much stranger, at least when it comes to interacting with fluorine. Fluorine will take every other element on the table, every single one of them, except xenon, to its highest possible oxidation state. Xenon's the weirdo. Xenon likes oxygen better. Oxygen will take xenon all the way up to +8. Xenon will also react with gold. There's a complex called tetraxenogold, gold atoms surrounded by 4 xenons, that can exist under some kind of bizarre conditions, chemically speaking, and both elements are notoriously unreactive. Now, as far as xenon's uses in the real world, camera flashes up until recently used a glass tube filled with xenon and dumped a very large amount of energy through it very quickly to cause the whole thing to flash very brightly. It's also used in strobe lights in exactly the same way. Xenon is also used as an anesthetic, and it has the unusual property from having a very high mass. In fact, xenon gas is about 4 times heavier than air. If you were to inhale a balloon full of xenon, instead of making your voice squeaky the way helium does, it'll make your voice sound deep and sometimes kind of demonic. It's kind of creepy, actually. Anyway, I'm going to extract xenon in this episode from a camera flash tube. So, let me show you how that works. This here is a camera flash unit that I picked up at Goodwill. And inside, it contains a small glass tube filled with xenon. So I'm going to take this apart and get out the flash tube. But first, I guess I'll show you what this thing does. Probably a good idea to take the batteries out first. As a matter of fact, no, I don't know where the original handle for the screwdriver went. Let's try a different bit. Aha! Okay, this is the part where I need to be really, really careful. Because that gigundous capacitor right here is still holding one heck of a big charge. So, carefully short it out. Yay! Yeah, that was holding a rather large charge. And now it's not. That rather large, loud charge in that capacitor is the energy that's normally dumped through the xenon tube in order to cause it to flash. And that's enough energy to probably croak you pretty bad. Okay, let's see what all we have here. This here is the piece I'm interested in. The rest of this will become useful a little later. Okay. Now, a quick explanation of how this works as a flash. The capacitor here will charge up to between 200 and 400 volts. Let's see what this one's rated for. It doesn't say. Okay, but that'll charge to between 2 and 400 volts, and there will be a massive amount of energy stored across the capacitor. Then onto the white lead, a voltage of about 4,000 volts will be sent. That'll ionize the xenon, creating a conductive channel for the entire large amount of energy stored in that capacitor to dump through. That causes the xenon to get hot enough to glow white hot for a fraction of a second. And by then the capacitor's done dumping its energy, the arc extinguishes, and the lamp goes out. Let me show you something else a little flash tube like this can do. Okay, so here I have the high voltage power supply that I've used in a couple of other videos. And here is the xenon strobe tube from the camera flash. So let's power it up. And the camera is just seeing an oversaturated bluish-white glow. What I see is little mini lightning. There we go, torch mode activated. Now you can almost see the lightning, kinda. But yeah, that lightning like that is because the xenon inside the tube is at a pretty decent pressure. It's probably still well below atmospheric, but the higher the pressure, the whiter and brighter and skinnier and stringier the lightning looks. I used to have a larger xenon tube, and by larger I mean like 10 inches long. And it produced much more hazy, blue, diffuse kind of lightning. So anyway, let's see about getting this xenon gas here into an ampoule. Alright, this being an ampoule to store gas, the usual thing is to stretch it out first, so I have a thin neck that's easier to seal under vacuum. So here goes. Alright, so now I just let that cool off, and I can get ready to fill it with xenon. Now that the test tube is cooled down, it's time to snip the wire leads off of the xenon tube so they don't get in the way. Here we go. I was going to put the xenon-filled tube inside of the plastic fill stem of my vacuum apparatus, but as you can see, the tube's just a little too thick. So hold on a sec. I'm going to use a piece of some somewhat thicker tubing to make an adapter. Okay, so the thin tube fits tightly into here. The xenon-filled tube can fit into here. And let's get this into the vacuum line. Pull that adapter out. Carefully put this tube in so I don't break the xenon-filled tube prematurely. Connect the stopper to the test tube. And let's pull a vacuum on this and make sure we get the normal air glow. Okay, that's the normal air glow. I'm going to let the vacuum pull for a little bit on that. Just to get the pressure as low as I can, so there's as little contamination as possible with the xenon. Now I'm going to clamp off this tube here. Double check that that's leak proof. Yep, the air's still glowing in here. But I want to make sure I keep a vacuum on the system anyway, just in case. Okay, now when I release the xenon from here, hopefully, as it distributes into this space here, this should start lighting up bright blue instead of pale purple. Okay. It's probably not super impressive, but that is the dark blue violet of xenon gas. I actually managed to capture it. Heck yeah. And that went out. Oh. Air leaked in. That's mighty interesting. But it didn't leak in on this side. So it is a bit wonky looking. Okay. If you can see that, that is not air. That is xenon. Okay, since this doesn't have the usual hanging hook in it that most of my ampoules have, what I'm going to have to do is hot glue the hanging hook to it. So, little hanging hook made of black wire. Put a good layer of hot glue on there. Make sure it still glows. Go. Lay the hook in the glue. There we go. It glows, it's just faint. See? Still glowing. I was hoping that the other power supply would make this glow more brightly, but it didn't. That's okay. Maybe another time I can get a larger sample of xenon so I could be able to experiment with the gas pressure to find the one that'll produce the brightest glowing ampoule. Still, this is definitely xenon. Ooh, definitely xenon and high voltage. Be careful with high voltage. So there it is, xenon, and I'm pleasantly surprised I got it to stay in the ampoule. After the failures with oxygen and chlorine, the oxygen one doesn't glow anymore. The bad thing is, though, my camera is just not picking up the glow from the xenon correctly. What I'm seeing are the pads of the plasma where my fingers are touching the glass are a pale blue, and the streamers are a deep purple, and then the line of plasma against the coaster is almost an electric blue indigo kind of color. And the camera's just seeing everything is this uniform bluish violet and hazy and indistinct, and yeah, I'm a bit disappointed with the camera, but I'm absolutely delighted with finally having a sample of my favorite element on my table. Anyway, if you enjoyed this, hit the like button. If you know someone else who would enjoy it, hit share. Hit subscribe if you want to see more. And don't be afraid to leave a comment. Like, tell me what your favorite element is. See you next time.